So it's asking us to find the derivative of this function, 1 divided by x squared minus 3 times x squared plus x plus 3. Now, what's important here is to determine what rule you need to use. Well, most of the time I say, well, if you say times when you're reading the problem, it's a product rule, and if you say divide when you read the problem, it's a quotient rule. Well, that kind of gets complicated right here because you say both. But what you're dealing with is a function divided by a function. That's the overarching problem. So we're going to use the quotient rule, okay? Because we have something divided by something, okay? But another issue is that the something right here in the denominator, okay, that's a product. So what we're going to end up having is a quotient rule with a product rule inside of it. So I'm going to start by writing my quotient rule down. If you have an n of x, numerator, divided by a d of x, denominator, and you're taking the derivative of that, then it will be the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator all over the denominator squared. Okay, so what I'm going to do at this point is label our numerator is 1. And I don't know why I put it in parentheses, is 1. And the derivative of our numerator is 0. The derivative of 1 is 0. Our denominator, when we're taking the derivative of our denominator, that's when the product rule all of a sudden is going to happen in the middle of this quotient rule. So now I have to go off and think, okay, let's just go to La La Land for a second. So I'm just in La La Land for a minute, pretending that this is the derivative that it's asking me to do. And this guy right here, who is the denominator inside of my quotient rule, by himself, he is a product rule. So the product rule goes, if you have an f of x times a g of x, write down your f of x, multiply it by the derivative of g, and then say g and multiply it by the derivative of f. So I'm going to label here too. So f of x is x squared minus 3. F prime is 2x. And then g of x is x squared plus x plus 3. And g prime is 2x plus 1. So plug all of this new info into this guy, and we get that derivative is x squared. And see, this is the derivative of the denominator really for this whole other problem right here. Okay, so that's why I labeled it d prime. Okay, so product rule says f times the derivative of g, so first times the derivative of the second. So first function times the derivative of the second. Well, we wrote that right here. So 2x plus 1 plus the second function times the derivative of the first. So I'm going to FOIL this out. to get 2x squared. X squared times 1 is, ooh, sorry, that's 2x cubed. 1 times x squared is x squared. Now negative 3 times 2x is negative 6x. And then negative 3 times 1 is negative 3. So that was this side. I don't really have to put brackets around it, but I will, or parentheses for that matter. I kind of overuse them sometimes, but I like to visualize things. So now I'm going to say 2x times x squared, 2x times x, and 2x times 3 to simplify this side, and I'll get 2x cubed plus 2x squared plus 6x, okay? And again, I didn't really need those brackets. I just wanted you to see, this side versus that. Well, now I'm just going to combine like terms to get 4x cubed and 3x squared. The 6x's completely cancel because one was positive, one was negative, and then there's a minus 3 in the back. Okay, so this is the derivative of our denominator. I'm going to copy paste him. Remember, I went out into La La Land. Oops. I'm going to undo that. Okay, so I copied and pasted him right here, and now we're back at the quotient rule for this original function, and we're gonna just kind of forget that we had to go off in La La Land and get the derivative of one of our parts for the quotient rule. Now we're just going to follow the quotient rule. So finally, y prime is the denominator, and I get that from right here. Oops, didn't mean to do that. Y prime. Okay, so we first start with the denominator. Times the derivative of our numerator, which is 0. Well, that's going to be fun because anything times 0 is 0. So that's nice. Minus, okay. So now we say the numerator. Oops, I didn't. Now we say the numerator, which was 1. And that's nice as well because 1 times anything is itself, right? Times the derivative of our denominator, which I had to go off and do in La La Land. Okay, so 4x cubed plus 3x squared minus 3. All over the denominator squared. And I'm getting the denominator squared from the rule right here, and the denominator squared, the denominator is right here. So let's see, 4x cubed plus 3x squared, no, let's see, x squared minus 3 times x squared plus x plus 3, all squared. So now, to simplify this guy, I've done the calculus. Let's just simplify using some algebra. all of this goes away because of that 0. And now I'm just distributing really a -1 to that trinomial to get -4x cubed minus 3x squared plus 3 all over. Really, you can leave it like this, the denominator, or you can call it x squared minus 3 squared and x squared plus x plus 3 squared. I don't care how you leave that denominator. Nothing really factors from here, and so nothing crosses out, and you're completely done.